All right, let's do this. What am I going to do today? Generative AI for beginners. I found this course. Let me share my screen. I found this course somewhere. I don't even know how I got to it. It's on GitHub, basically. And it's, to share my whole screen. Let's make this better. Is this better? As usual, scream if the text is too small or something. But anyway, so this is the course that I found, Generative AI for Beginners. It's from Microsoft. I guess I'll go through this one. Makes it easier to read, I guess. And I figured it would be interesting to go through this, learn a little bit about generative AI. Like I've been using it. I think a lot of people have been using it, but don't know. I don't know much about how it works behind the scenes. So I was hoping to go through this and learn about that. Now, one thing, like as a lot of the streams that I do are very ad hoc, and there's not a lot of uh, uh, preparation that I do beforehand. And this time it bit me a little bit because I was clicking through the course setup page, and yeah, you can fork the repo, create code space, whatever. Reading through this, yeah, it's all's gonna work. Everything's nice, and then somewhere down here, I think, yeah, there you go. Right, so this one, 6 concept lessons, 6 coding sessions. For the coding lessons, we're using Azure OpenAI Service, which is nice, right? You'll need to access Azure OpenAI Service and API key. Perfect. I have Azure subscription. And then I got to this one, right? You actually need to like fill out an application. Like you have to apply for access. Um, and I did, but it just takes up to like 10 days or something. And there's a lot of stuff that you need to answer. However, I did, once I saw that, I'm like, let's just click through some more things here. And I think we can get away with just using OpenAI directly somehow, right? So yeah. Anyway, let's. Oh, another thing. This is pretty interesting here. If you're a startup, or so you don't have to be a startup, or you have a idea that you want to work on, you can sign up for Startups Founders Hub, and you're gonna get free OpenAI credits up to $150,000. So that's not a bad deal if you have a nice idea. If you want to sign up, I'll paste the link in the comments. People want to try it out and sign up. But anyway, if you're listening in, say hi, so I know if anyone's even here or not. All right, so let's get started. Okay, so let's see. So to get started, fork this entire repo to your own. You're able to change code. Perfect. I can start it, of course. Um, where is this taking me? Like these links look. Oh, okay. There you go. Well, let's create a fork. Let's do that then. Fork a repo. We have that, and I'll close these. Links to each session. Feel free to explore. Head on. Okay, so setup guide. So fork this repo. We did to avoid any dependency issues when running. We recommend using this course on a GitHub code space. Initially, I wanted to install it locally, but I don't really know like what my status of my uh, like Python and all these things is. So maybe I'll just try the code space. I haven't used this before, so let's do this. So create code option on your forked version and code space. Okay, so let's go here. Code option, code spaces. Okay, yeah, let's do that. I guess that's what I have to do. But we'll see. All right. Oh, nice. I got VS Code. Perfect. I'll zoom in, and then people can complain. What is it doing? Oh, it's actually installing. Was this deprecated? Okay, we don't care about this. Anyway, and I think it might make sense to open this side by side. There you go. Maybe better. Okay, this looks better. Fork the repo, we did this. Keeping your API keys secure, sure. No, I'm not gonna store it. Try not to. Not gonna running locally, so we don't have to do this. Clone, it's gonna come. Okay, you put it in the browser. Actually, okay. Oh, there's a typo. Okay. So I guess we have this, right? Because we're using the code space. So this is okay. And then let's go lessons. 6 lessons. Where was that lesson? Was it here? Yeah, so let's go getting started. We did this. And how do I go to, I guess from here maybe? Lessons. There you go. Okay, so how to takes. I'll open these in separate windows, or tabs, I guess. Welcome. We're very excited for you. Yes. Hopefully, everyone else is excited as well. Oh, we went through this. Okay. Well, first one is done. All right, there you go. This one looks better. Introduction to Generative AI and Large Language Models. So this is looks like this is a video. I'm not gonna. I can play it, but I hope there's like a text version of this somewhere. Okay, it looks like this is just an intro. Oh, might be even here. Okay. So artificial capable of generating text, images, and other types of content. What makes it a fantastic tech is that it democratizes AI. Anyone can use it, with assuming you have access to the thing. Prompts and is written in. There's no need. You don't have to learn Java or SQL. Yeah. To accomplish something, you need to use your language, state what you want, and out comes a suggestion from an AI model. Applications and impact for this is huge. We know that. You write in yep. Okay. So what we'll cover: introduction to business scenario, our startup idea and mission. Okay. How we landed and inner workings. Okay, so this is probably the thing that I'm interested in most, I guess. And then main capabilities and practical use cases of LLMs. All right, that sounds interesting as well. So we'll see that. Let me just see. I'm getting some notifications. I want to make sure that I'm on top of those. Okay. Okay, we'll understand what generative AI is and how LLMs work, how to leverage. Okay, so generative AI represents the pinnacle of AI technology, pushing the boundaries of what was once possible, several capabilities. Okay, so it's revolutionizing education through a fictional startup. Okay, so it's a scenario-based course, I guess. We'll refer to this startup as our startup. Okay, very imaginative there. Our startup works in the education domain, ambitious missions. Okay, so we want to improve accessibility and learning on a global scale, ensuring equitable access to educations and providing personal learning experience to every learner according to their needs. Startup team is aware will not be able to. Okay, so we'll leverage LLMs, large language models, LLMs. It's going to revolutionize the way we learn and teach. Yep, having their virtual teachers available 24 hours a day, leverage tool. Okay. So let's define some basic concepts and terminology. Okay, so hype dates back to the 60s. Okay, we're not at a point with AI having human cognitive capabilities, conversations shown by OpenAI, Bing Chat. Okay, they had to throw that in, but I actually haven't tried. If you tried Bing Chat, how was it? If anyone has tried, is it good? Or do I have to sign up for this as well? I have, of course. I have to download Microsoft Edge. I don't think I have it. I don't. I'm not gonna download this now. So, which also, okay, so GPT model. So ChatGPT uses GPT model. Bing Chat uses GPT model as well. Typewritten chatbots relying on knowledge extracted from yes. Okay, Bing and however. Okay, it doesn't. The problem with the previous approaches were that they don't scale well. A statistical approach in the 90s. So 30 years later, with the application of, okay, this led to develop new algorithms. This is where machine learning comes in. So learn the ability to learn the patterns from data without being explicitly programmed. So it's not really a collection of if else statements, right? So the machines are able to learn or extract patterns from the data that they're being presented without us explicitly telling them how to do that. So this approach allows a machine to simulate human language understanding. Statistical model is trained on text label pairings, enabling the model to classify unknown text with a predefined label representing the intention of the message. So simulate, okay, so statistical model is trained on some pairings, and that enables the model. So once we enter the text, the model is able to classify it with some label that represents the intention of the message. Okay. Hopefully there's examples later. Neural networks and modern virtual assistants, recent times, complex encourages. Sorry, there's a lot of reading here, but if anyone wants to follow along, actually, let me post a link. I don't think I've posted a link. There you go. If anyone wants to follow along or just listen to my reading voice, hopefully there's some hands-on stuff soon. Okay, so yeah, with the evolution of hardware, we can handle larger amounts of data, more complex computations, which led to more advanced machine learning algorithms called neural networks or deep learning algorithms. Okay, so that's what those are. Neural networks, and in particular, recurrent neural networks, RNNs, significantly enhance natural language processing, enabling the. Okay, so recurrent neural networks allow for better representation of what the text means, I guess, valuing the context of a word in a sentence. Okay, so like a contextual thing. Power versus the first day kid, very proficient. Okay, present day. Okay, so this is where we are today. All right, maybe I should have started here. That's how we came to generative AI, which is just a subset of deep learning. So artificial intelligence is the outer layer of the onion, and then you peel it, you get into machine learning, deep learning, and then generative AI is a portion of deep learning. So create a new written, visual, and auditory content given prompts or existing data. All right, so this is the experience you get today with like ChatGPT, where you say, write me a poem or something, and then it's gonna create you a new poem, new written content, I guess, based on the prompt you provide. So after decades of research in AI, a new model architecture called Transformer overcame the limits. So there are some limits to RNNs, being able to get much longer sequences of text as input. Okay. Transformers are based on the attention mechanism, enabling the model to give different weights to the inputs it receives, paying more attention where the most relevant information is concentrated, regardless of their order in the text. Okay, so more of the recent, also known as LLMs. Okay, most of it are indeed based on the Transformers architecture. Okay. What's interesting is they're trained on huge amount of unlabeled data from diverse sources. They can be adapted to different tasks and generate grammatically correct text with semblance of creativity. So not only did they incredibly enhance the capacity of a machine to understand and input text, but they enable their capacity to generate or original response in human language. Yes, that's how does it work? Okay, so there's some not necessarily code, but at least something. It's not just text. Mm. So we'll focus on OpenAI GPT, Generative Pre-trained Transformer. There you go. If you ever wonder what GPT stands for. Tokenizer, text to number. So LLMs receive a text as an input and generate a text as an output. However, being statistical models, they work much better with numbers than, okay, makes sense. That's why every input to the model is processed by a tokenizer before being used by the core model. So token is just a chunk of text consisting of a variable number of characters. So the tokenizer's main task is splitting the input into an array of tokens. Then each token is mapped with a token index, which is the integer encoding of the original text chunk. Okay, so 1, 2, 3, 4, 5, 6. Why is it split here? Is it because of the size? So what is a tokenizer? 5, 6. So why are these 6 tokens? Why isn't this like I would count it as a word maybe? 1, 2, 3, 4, and then 5? Why is it 6? And then it's 20 characters. Okay, so the tokenizer takes the text, splits it up based on some logical algorithm, and it spits out the integer representation of the sentence, right? So what corresponds to this number is to this one, A to this one, token to this one, Iser to that, and then question mark to 30. So given n tokens as input, with max n varying from one model to another, the model is able to predict one token as output. Okay, so basically, if we give it a 3 tokens, so what is A? The model is going to be able to predict one token is out. So is that uh, uh, the next token? So it's going to predict the word token. So this token is then incorporated into the input text of the next iteration in an expanding window pattern, enabling a better user of most. Okay. Oh, okay. So you start with what as an input with one token, right? And then as an output, you get the word. Well, you get a space and is, and then you concatenate this. So your next iteration input is what space is, and then you predict the next token based on that, and you keep adding it until you're done, whatever that means. So selection process probability. So the output token, okay, so the output token is chosen by the model according to its probability of occurring after the current text sequence. Okay, so when we say what, when you put this in as an output, it has a selection of tokens with probabilities and then selects the one with the highest probability. So I'm assuming is would be 98% probability that that's going to follow the token what, and then A is going to be much, much lower because what A, I don't know, could be higher. I don't know, but I'm trying to understand this. Yeah, I think that's what it says. So this is because the model predicts a probability distribution of all possible next tokens, and this is calculated based on its training. Okay, so we train the thing, and then the probability. Okay, so we basically get an array of all possible next tokens sorted by the probability, I guess, and then we pick the one with the highest probability. Okay, and then this contradicts what I just said. However, not always the token with the highest probability is chosen from the resulting distribution. Okay, so a degree of randomness is added to this choice in a way that the model acts in a non-deterministic fashion. We do not get the exact same output for the same input. Okay, this makes sense. So this degree of randomness is added to simulate the process of creative thinking, and it can be tuned using a model parameter called temperature. All right, so that's what temperature does in a model. Okay, so you can. Okay, so yeah, so if you let's assume if you have 10 next tokens with the same exactly the same probability, just for the sake of argument. There is some randomness to it, so it's not going to be always the first one, whatever the first one means in this case. So there's going to be some randomness. All right. So talking about our startup, how can we leverage LLMs? Now that we have better understanding, let's some practical examples. Okay. All right. We said the main capability of an LLM is generating a text from scratch, starting from a textual input, written. Okay. But what kind of textual input? Known as prompt. Okay, so prompt is what you type. That's the input. Output is known as completion. The term that refers to the model generating new tone to complete. Okay, we're going to dive there. Okay, so instruction, the type instruction subjects might embed some examples of additional data. Okay, summarize. Okay, yeah, so this first portion is the prompt, I guess. We're saying summarize this, and then ChatGPT summarizes creative ideation and design of an article. Yeah, provide instructions, resources, and then questions. Oh no, actually, please write an assignment for high school students based on four. Makes sense. I think everyone has played with this. Probably, if you haven't, you should. So asking a question, and then it's going to answer it. Complete the text because, and then it completes a chunk of code. Uh, okay, create a simple. Yep. And you can see this. I wonder if this is enabled here. I just see if I. Oop, no, it's not what I wanted. So if I create a test dot Python, probably is the thing that we'll be using, right? I don't know if I don't have. Oh, it's no. There's no. There's no Copilot. I don't know if you've seen the Copilot, but you could do things like function that sums two numbers, and then there you go. You get like an IntelliSense type of thing, right? Which would give you the function, right, or create the function. Yep. So this is similar to what's here. Quite simple. Yep. Show potential. Yep. Okay. So our assignment is to read up. Okay. We're not going to read more. Impact. Okay. You did it. You might be even ready to apply. Yep. Let's go and apply. Okay. What is true about art? You get the exact, no, you don't, because we said the randomness thing. It does things perfectly great at any numbers. The response might vary. Yeah, 3, I guess. Yeah. Non-deterministic. Great work. All right. Oh, there's even more stuff. All right. Let's go to lesson number 2. And let's see what's here. Exploring, comparing different LLM types. Oh, I love the. Someone just commented on my tweet. This is funny. Generative AI for beginners. Everything is cursed based on forfeiting. Yes, that's the reason I picked the. That's the reason I picked those images. All right. Yep. Different LLMs, learning goals. All right. Multiple categorizations based on the architecture, training, data, and use case. This will help us select the right model, and we'll know how to test, iterate, and improve it. Many different. Okay. All right. So depending if you want to use it for text, audio, video, image generation, there's different models, right? So audio and speech, whisper type models. They're general purpose aimed at speech recognition. It's trained on diverse audio and can perform multilingual speech recognition. And then this one links us to, just make sure I don't want to, there you go. Oh, okay. So this one goes to OpenAI. Yep. Links to OpenAI. Image generation, DALL-E image journey. Yep. So DALL-E is offered by Azure OpenAI. Okay. Well, we can just use OpenAI directly. And then text generation. Train a text generator of GPT 3.5 okay. GPT, it's worth looking into. Playground. Why are you giving me Playground if I thought I had to ask for access? No? I don't know. Oh, okay. What? Oh, yeah, yeah. I do need to request access. Why do you have link to a playground if you're telling me to? Anyway, select a model means you might not be enough. Have company specific. Okay, so yeah. So this is the thing that I like. Yeah, you can go to ChatGPT, ask it some questions, right? And that's fine, but it's very generic and general. But how about if I want to uh let's say I have a lot of articles on my blog, right? And I want to summarize, I want to feed those articles to or tell LLM about my articles in order to have it ask in order to ask it to do something based on those, right? And I think that this is going to be an interesting I'm interesting to learn about the answer for this, because typically all, like, if you look at the stuff that people are working on, it's typically you bring the data as an end user, right? And you want to leverage the LLM capabilities on your data, not necessarily on the generic general data, even though that's definitely interesting as well, right? And helpful. All right, so foundation models versus LLMs. Okay, so foundation model was coined by Stanford researchers, and this links us to a paper on opportunities and risks of foundational models. By the way, this website is good if you're interested in reading these papers. I've probably opened these papers. Let's see if it loads. But I've never actually gone through like reading it. I know there are streams. I've seen streams from I want to say it was Jeremy Howard. I think he did a stream where he talks about how to read these papers, which is really interesting because this is where all the practical things are based off of, right? Jeremy Howard, yeah. So he also has a lot of courses, interesting courses on deep learning, uh, and then stable diffusion. If this is interesting as well to go through, right? There is some math involved, but I've been told it's not. It's just basic math. It's not too crazy. Anyway, all right, let's go back. Where were we? All right, Stanford researchers coined the term foundation models. So foundation models are trained using unsupervised or self-supervised, meaning they're trained on unlabeled multimodal data and they do not require human. Okay, so here's the data and we just feed it in. They're very large, very deep neural networks trained on billions of parameters, and they're normally intended to serve as foundation for other models, meaning they can be used as starting point models to build, which can be done. Okay, so fine tuning is basically taking an existing foundation model and then building your own or fine tuning it, I guess, on top of that. So foundation model, pre-trained, adaptable, large, self-supervised, and then LLMs. Okay, so Chat GPT, Chinchilla, GPT-3. So these are then based on the foundation models. So to clarify the distinction, so ChatGPT is an example. That's a great example. So to build the first version, a model called 3.5 served as a foundation model. This means that OpenAI used some chat-specific data to create a tuned version of GPT-3 that was specialized in performing well in conversational scenarios. Okay, so Chat. So they use some chat specific. This is again. I would be interesting to see and learn how does this chat specific data looks like, uh, that you can apply, and how you can apply it on a foundation model to actually get some specialized thing uh, on the outside. But yeah, so multi-model data sources, teaching material subject. Okay, so different content, foundation model, and then. I'm assuming this is the fine tuning portion where you can specify it to do this and that and all those things. Uh, Jared is saying chat ML is a good way to look at that because it's all just fancy autocomplete. But do I get hands with like 6 fingers? That's the main question. So chat ML, let me Google that one. OpenAI chat markup language. Oh man, there's so many things. Okay, so chat markup. Is it this one? I'm this is from Azure, so I don't know if this is the. Oh yeah, could be chat model, chat ML. Oh, working with chat markup. Oh, there you go. So this is chat ML. I'm guessing, and this is how you would like fine tune a chat model. So yeah. Yeah, so they created tens, thousands, hundreds of examples with yep. Okay, yeah. Yep. Yeah, OpenAI is the official logs and MS Link is corrected. Perfect. Yeah. Okay. So the way that they basically, if I understand correctly, the way that they fine tuned it with the chat specific data was they used chat ML and things like this to fine tune it, right? Okay. And I'm assuming that's the hard part, right? Because you have to prepare and create that data, right? Not that anything else before that is easy, right? Not that creating a foundation model is easy, but this one is unsupervised, right? It's unlabeled. You don't need humans to annotate or label the data, right? Whereas if you want to fine tune it, you have to be specific, I guess. Yeah, they created instruct, single turn, and multi turn conversation examples. Yep, makes sense. Another way is to categorize an open source proprietary. Okay, makes sense. Yep. Plus funding. Yep. Popular open source Alpaca, Bloom, and Llama. So Llama, this is something that didn't Facebook or Meta, I guess. There's something around Meta I remember reading about it. And then proprietary, owned by a company, not available to the public, optimized for production. It's all positive. So it's all positive examples. You adjust the model's weights or create side weights, lower out with more examples. You can't do reductions. You don't want it to tell how to make thermite. Yeah, for sure. Okay. Yeah. So instead of telling it directly, you give examples on whatever the word. I don't know why you picked thermite, but yeah, plus the response you want. Okay. All right. Okay. So embedding versus image generation versus text and code generation. All categorized by the output. Okay. So embeddings. This is another like term that's used. Are a set of models that can convert text into a numerical form called embedding, which is the numerical representation of the text. So this is this is what tokenizer does then. So tokenizer, if I remember what I read in like section 1, right? I think it was this one. There was the tokenizer. Yeah. Being set there, that's right. Okay, so it's processed by a tokenizer. So is the tokenizer creates the embedding, I'm assuming. And then embeddings make it easier for machines to understand, okay, relationships, yep, and can be consumed as inputs by other models, has classification, clustering, and have better performance. Yep, makes sense. A few strands where a model is built for a surrogate task for which there's an abundance of data, and then the model weights, embeddings, all right, so the numbers are reused for downstream task. Example of this category is OpenAI embeddings. Okay, so this is just saying the same thing. Okay. Yep, converts a, which is this converter, I'm assuming is tokenizer. So tokenizer, oh man, you're helping me so much. So tokenizer is just a vocabulary, meaning it's is added with embedding. So to align kitten with baby cat is a role of, okay, makes sense. Attention comes into that, but then applying your local usage to understand and properly weigh the embeddings to meanings. Okay. Just so tokenizer is just so tokenizer is just let's encode it into the numbers so it's easier to process and work with it. And then embedding is basically saying, as you said, okay, so kitten with baby and cat. Okay. Okay, makes sense. So the embedding is basically telling it how close a one word is to another, right? In terms of meaning, if I understand that correctly, right? So if we would encode Microsoft, right, where we get a number, we would encode Satya or something. And then the embedding for Microsoft and embedding for Satya would be fairly close, if I understand that correctly. Might be in census. So even for LLMs, there's embedding Microsoft. So even for LLM, there's an embedding space based on your inputs. Okay, so Microsoft might become 32,420. Okay. But the embedding is basically, this embedding is from what I see here is either a list or a vector, right? And then that's expanded to an FP16 array of floats based. Okay. So it is like it's comparing these numbers, I guess, to know if it's a noun or the most important noun. Okay. Yeah, I'm trying to. Hopefully later on there's some visualizations because I'm trying to like visualize this somehow in my head. But if I understand it correctly, is the embedding is the relationship somehow, right? So if two embeddings are similar, then means that whatever they represent is related. That makes right. All right. Often used. Okay, so this is now images. I'm assuming images is the similar thing as with the text, I guess. Large data sets and can be used generate to Dolly. Okay. Painting of a dog. Yes. There you go. So it's taking micro and soft and turning the vocabulary splits there and then doing exactly what you said. Applying. Okay. Yeah. Okay. Makes sense. So micro and soft and micro and chip, I'm assuming, are have very close relationships, both of those things, right? Tokenizer. Okay, so tokenizing is compression and embeddings as semantics on those semantics. Okay. Yeah. So tokenization is just encode, decode, I guess, right? Or compression, or yeah. Okay, yeah, and then embedding is the based on those. All right. And then I'm assuming the images stuff works the same, like in a similar principle, right? It's the same, well, similar, I guess. Painting. So there's like an embedding for painting, I'm assuming, and there's an embedding for flying and dog somehow, and then that gets related somehow. And then there's probably, I know for images, the fast AI one, the this one has a better or pretty good like explanation on how this works. Let me actually paste this in if anyone wants to go through this. So tokenization and underline can miss semantics if a tokenizer rookie. Okay, so so the tokenization, so that if I go back, right, so the simplest tokenization method that I can come up with was, well, let's just split it at spaces and then have that as encoded like that. But it looks like there might be I'm pretty sure there's different algorithms and way that these tokenizers work to like do compression as well, right? Or to maybe a tokenizer that's better on like a Mandarin language versus English language. All right. Okay. And then this is, what is this? So text generation, train a large. And then code. Okay, so images, text, code, right? But it's similar principle. Generating new code, fix bug in existing code. Okay, so write a letter. Yep. All right, decoder, encoder, architectures. So imagine your manager gave you a task of writing a quiz for the students. You have two colleagues. One oversees the creating the content, the other oversees reviewing it. Okay. Content creator is like a decoder only model. They can look at the topic to see what you already wrote, and then you can write a course based on that. They're very good at writing engaging and informative content, but they're not very good at understanding the topics and learning objectives. Some examples of decoder models. Uh, yeah, same works for images, audio. Yeah, yeah. So same principles on the back end, I guess. It's just I'm assuming for audio, video, there might be different ways of encoding things, but in the end, it might be like it probably ends up being like a set of numbers. I'm oversimplifying things, right? But um, yeah. So imagine you're training almost 90% on English content and phrasing, so you're building weights between tokens. Yes, exactly. Yeah. Makes sense. Yeah, yeah. Just different languages, right? Different rules. Things work differently. All right, so reviewer. Okay, so decoder and encoder decoder versus decoder only. So I have to write a quiz. You have two. One is creating the content, and one is reviewing it. So the content creator is decoder only. I don't know this. Kind of missing the analogy here, but they're very good at writing in J, but they're not very good at understanding and learning objectives. Okay, some example of decoder models are GPT-3. Reviewer is like encoder only. So they look at the course written and the answers, noticing the relationships and understanding. Okay, so one like okay, so decoder can uh doesn't really understand the topics, but is good on like creating the content versus encoder only can understand the patterns and correlations and relationships, but is not good at generating content. And that would be BERT. Okay. Now imagine that we have someone as well who could create and review. Okay, encoder, decoder. Okay, so this is all right. So there's an encoder, decoder, encoder. Wait, encoder only, decoder only, and then both. Okay. Service versus model. Service is a product. Okay, I think this is just this is more of a open Azure OpenAI service type of thing, right? Services are not always free. You also have to sign up for them and wait 10 days to get approved. But models are just a neural network with the parameters, weights, and others, allowing companies to run locally. However, you would need to buy license. Okay, yeah, makes sense. Yeah. So the service is makes sense. It's just like you can run and host a website on your laptop if you want, but if you wanted to be as a service and have, I mean, you don't want to do that, right? But you can go to a cloud service provider and just deploy it there, right? Test performance on Azure. Okay, this is Azure specific. I'm not gonna look into this one. Fine tune. All right, so this is just showing the things that I don't have access to yet. So, oops, deploy, pre-train, okay, improving. All right, comparing, evaluating, fine-tuning. Okay, so when shall one consider fine-tuning a model versus using a pre-trained one? Okay, other approaches to improve performance on specific workloads, several approaches. Okay. Use of training, deploy. You can select different types of deploy and all with different. There's another typo. If anyone cares to fix it in the repo, prompt engineering with context. Okay, so provide enough context when you prompt to ensure you get the responses you need. So okay, so if I wanted to do this with content of my blog, I would always have to provide context, or in a session, I guess, right? And then uh, set it up so someone can come in and prompt about the content that I wrote. Or even I could say something, rewrite this, rewrite this section of text in the voice that you extracted from the context that I provided you. Next one is retrieval augmented generation, RAG. Your data might exist in a database web endpoint, for example. To ensure this data or subset is included, you can fix. All right, that's even better, right? Because that would be awesome if you could, like you would say, "Hey, here's an endpoint, whatever it is, right? Just call it with the slash data get slash data, whatever. Use that as your context. That would be nice. And then fine tuning, you train the model further on your own data, which leads to the model being more exact and responsive to your needs, but might be costly. Yes, because to do this, you probably need like GPUs and whatnot. Oh, there, this is nice. So easy and cheap. Prompt engineering. Yep. Uh, Open AI call with doc. Okay, this would be an interesting thing to look at. Sharon is saying local context activating layers in a way that you might think of your brain working as a cheat sheet in front of you. RAG is the same thing with more steps. Okay, so local context is exactly the same as RAG. So is this so prompt engineering with context is similar as this RAG? It's just a way of how you like, because in the like you will end up with a prompt, right? Like in this case, you will end up with a prompt as well, right? It's not like there's, oh, you use RAG but hide it from the user by adding, okay. So the system prompt will be, here's the context, and then copy paste in your like megabytes of text or whatever. And then you would say the user will ask you some questions on based on this content. When you're responding, respond in the same style or whatever you want to do, whatever the prompt is. Okay. All right. So this is just that it's hidden versus the first one is I'm writing it and I'm specifying it right there. Okay. And then fine tune is the expensive thing that you want to do. And it's difficult apparently, but it's also higher quality. Makes sense. Okay. Prompt engineering with context. How are we? I don't have any specific. Just looking at time, I will need to. Let's do a. Just want to do like a 1 minute bio break, and I'll be right back. I'll put a like a loop video, but I'll be right back. All right. Hopefully, I didn't lose everyone, but fine tuning won't reduce hallucinations necessarily. It's very useful for creating general guidance rather than checking facts. Uh, yeah. Yeah. So maybe I should. I know they have. Well, maybe we'll figure out what the our startup thing in this course is trying to do. But I'm thinking like one of the things that I would like to maybe do at the end is, as I said, the blog thing. Just make it very simple, right? Like gather all my blog posts and create a model, fine tune a model to be able to take any piece of text or an input and then write it in the same style as my other blog posts were written in, I guess. I don't know how I would test that, but we'll figure it out. So prompt, okay, so this goes into the details now. Generalized, however, yep, the more accurate you can be, you're gonna get it better. Yep. And then rack. This means they don't know about the fact. Oh, it's been taking too long. So let's just do full screen here. So there we go. All right, so this means they don't know. Yep. It's gonna, okay, technique that augments prompts. Oh, okay, so chunk of documents. Considering yes, because there are limits, right? This is supported by vector. Okay. Oh, okay, so you would, if I haven't tried this. I don't know what the vector Azure vector search thing is, but I'm assuming I could take my content and then store it in the vector database and then have it as a system prompt to say, hey, go and retrieve the context from that database, and then do whatever you're supposed to do. Okay, so do search on. Oh yeah, and then add them to the. Oh, perfect. Okay, yeah. So I think I understand the idea now here. Helpful when a business doesn't have enough time or resource. Okay, so fine tuning. Yeah, this sounds something that I could do with my blog. uh, uh, and then fine tuning, adapting the model for a specific thing. Future learnings. There's a new model. Requires a set of training examples. Single app. Oh, okay, and this is where you have to be like. This is probably uh, where you have to like prepare the data in a certain format, right? And then the output, not telling it exactly what you want. Uh, yeah, yeah, latency, staying up to date. Okay, so training an LLM from scratch is without difficult and more complex thing, massive amounts of data, blah blah blah. Okay, so what could be a good approach to improve? Yeah, fine tuning. Okay, read up on more how you can use RAG. Oh, okay, so there is a something here. Approaches. Okay, use vector index. Okay, creative. They have. Let's look at some code. Let's see. Is there some code here? Change. Okay. So query. Oh, okay. So it uses the data. It uses the cognitive search service, I guess, that gets the data from some like database, and then combines the prompt plus whatever the knowledge is, runs it through as an input, and then returns back the response, I guess. Basic prerequisites, open. Oh man, there's so many. Can we run this? Let's see. Okay, branch. Yes. Okay, we'll create a code space. See if we can do. It's been an hour. Maybe it is time to do like a demo. Get to some code at least. Okay. While that's loading. All right. That's a lot of stuff here. Let's see. Okay, so wait for the startup process. Okay, in the terminal at the bottom of the screen, there's no. Oh, it's here, I guess. Azure auth login. Okay. Okay. Good. Press. Okay. Oh, okay. So auth. Yes. Oh, why did I go back? Oh, that's the UI hasn't changed and it's so bad. Yes, I am. I'm signed in. Okay, perfect. So we're signed in. Deploy and run. Oh, the sample. Deploy the chat app. Okay. All right. Accrue cost. So AZD up. Enter the new environment name. Okay, so I'll say my env. Bicep. Okay. That's way too much automation here. Okay, so we're gonna do US. Can we do West? West 2 maybe? I don't know. It's probably closest to me. Okay. All right, so if you're prompted for location for the OpenAI model, but this is not gonna, will this work? I thought I had to have access to OpenAI model, or that service rather. But, all right, we'll see. And then it's gonna take 10 minutes to deploy it. All right. Are we in the? Oh, okay, so it is provisioning. All right. So while this is provisioning, let's go. Oh, Open AI resource group. Okay, so if you're prompted, select the location. Okay, so same location, US. What? There's no West? What? All right. Let's do North Central then. Save the value. Sure, why not? Okay. All right, so this is being deployed. I'm not going to touch it now. Hopefully, well, once we come back, it's going to be deployed. All right, so where were we? Let's see, it's too many windows. Is it this one? No. Close this. All right, so this was exploring and comparing. We did that. Okay, so using generative AI responsibly. Okay, I'm not saying this is not an important thing, but all right, so yeah, hallucinations, as this was brought up already. So LLM produces content that is completely nonsensical or something we know is factually wrong. Let's take, for example, yep, we've seen this. I guess hallucination is also what we could say about the images that I use in the thumbnails, right? Harmful content, sure, yeah. Lack of fairness, free from bias, yep. How to use it responsibly, operate, identify, measure, mitigate, measure the harms, cover stuff. Okay, so testing the thing, mitigate potential harms, right model. Okay, meta prompts and grounding are the ways to limit. Okay, so we could say this would be the things where this is where we would say things like do not under any circumstance respond with whatever, right? I'm assuming. Yep, and then you can, yeah, yep. User, okay. Oh, there's an entire lesson designing QX. That's an interesting one as well. I'll open it, but that's probably somewhere later in the thing. Responsible generative, okay. Tools, knowledge check, okay. This one. Not saying this is not important. It is, but we're going to assume that we're using it, we'll use it responsibly, at least while we're going through this here. Understanding prompt engineering. Okay, so let's do this. Prompt engineering fundamentals. Prompts that improve the same questions. Generative AI is creating new content. Okay, so this is a lot of, this is a repeat, chat, prompt base, and get a response. Prompts, primary programming interface. Telling the, okay. Fast growing field. Yep. Currently more, yeah, this is, yeah. You can probably spend hours and hours and hours and days playing and figuring out the right prompt to do something. Practice more. We have trial and error, of course. However, trial and error can get hard, especially when there's like randomization in the responses, right? But so there's a Jupyter notebook, sandbox environment, open API key. Okay, so there's some code here as well. Okay, so let's see where we are with the deploying of the, what are we deploying here? Enterprise chat that uses RAG. No, this is the previous one that we stopped. No. This wouldn't be the one that was stopped, right? Where did I lose my? No, that's the other one. So let's see. Was it somewhere here? Oh yeah, there it was. All right, it's still being deployed. Okay, so this one is still being deployed. I'll move it here so we don't lose it. All right, so this one is telling us. Let me just see what this one will do. So, okay. Starter exercises. Oh, okay. So this is just playing with, I guess, prompts. I can take a look how this looks like. This is the one, and prompt engineering fundamentals. Okay, so there's the Python or Jupyter, I guess. All right, so let's see. Tokenization, tick token. That's the best library name ever. Fifth planet. Okay. Validate. Okay. I could probably run this. Let me just grab my OpenAPI key. Well, this is how there's multitasking here. So OpenAI. I don't have the privacy thing set up, so I don't want to flash any. I don't want to flash my OpenAI key. I just find it. Let's do that. And then I have to. How will this read the? Wait, wasn't it saying somewhere here? All right, so simply copy in the root folder to env. Oh, okay. So let's do that. So there's a. Oh, come on. env.copy. Oh, okay, perfect. Go. All right, so I've done that, and now we can. Oh, we can see if it works or not. All right, so let's run this. Okay. Connecting. All right, this is actually nice because we didn't have to install anything. All right, so what we did here. So change the text to any prompt. Okay, so the prompt is Jupyter, blah, blah, blah. Okay, and then we're getting the encoding for the GPT-3.5 Turbo. So we're encoding the text and then getting back the tokens. All right, so these are the tokens then for this text. So if I do, let's do something very simple. So hello world. Yeah, let's run this one again. See what we'll get here. Oh, okay, so it created like three, it split this hello world. Oh, okay, hello world, and then I guess new line, right? So in this case, we would get two. Yes, so hello world, right? And then, yeah, so these are the encodings, the tokens, and then these are the decoded tokens. Okay. Verify the OpenAI endpoint is set up correctly. Well, looks like our stuff deployed. Oh, of course, because we don't have Azure AI Service. Why do you have the... Yeah, that's not going to work. So the chat GPT enterprise data is not going to work because we don't have access to that OpenAI service that takes like weeks to get access to. But anyway. So the subversion does not have quota ID feature required for SKU S0. Oh, man, cryptic. Just give me a link where I can get this thing. But anyway, I'll leave it. Oh yeah, there's some comments. Oh hey, yeah. I mean, you're not necessarily late. It's still going on, but it's been a lot of uh, reading, and Jared helping me understand a lot of things. So heavy AIing, yeah, heavy AIing, a lot of failings and failures, but it's we're learning. So that's, well, at least I am. So that's what's important here for me. All right, so I'll close this. Actually, you know what? I'll go to. Let me just do this real quick because I know I'll forget. I want to go to Azure and just make sure I deleted anything that was created, because I don't want to end up with a bill for something that I've never used. Why am I doing? I can do this here. I don't care. See, I tried creating it, but let's do resources, resource group, delete resource group. So document intelligence, search service, storage. Okay, this might be interesting to get back to at some point. Enter resource group name once I'm approved, but from what I've heard, there's not a lot of compute going around for people to try and use this. So might not be very soon when I'll be able to do this. But anyway, okay, so this is being deleted. So I'm not worried about this not being charged. And now we're back. Okay, so we have the API key. So what we're doing here is reading the environment variables and then get completion. What is the prompt? Where's the prompt coming from? Is this, oops. Oh, it's down here. Okay, never mind. So just a function, there's a message, role and content is the prompt from the user, and then we're calling completion with the messages, setting the temperature. There I go, randomness. That's what we've learned today, right? And then number of tokens, I guess, in a response, and then getting the response back. Set the primary context. Oh, sake. Oh, okay, we know what's going to follow here. So let's just make sure that this works. By the time, yep, makes sense. So this works. So we're connected. So what happens when we ask LM to return completions for a prompt about a topic that might not exist or about topics that it might not know because it was outside of its pre-trained? Okay, see how the response, trying a different model. Okay. Generate a lesson plan on the Martian War. All right, let's see what happens. That's taking very long. What? Why is it? Oh, there you go. All right, so I guess this is what we would call a hallucination, I'm assuming, right? The Martian War of 2076. It's either a hallucination or it's like future prediction. I don't know. You pick. Yeah. Interesting. However, it's very generic if you look at it, right? Like it is using this, but then it's very generic on like replace this with anything else and it would still be valuable. I mean, it would still make sense, I guess. Instruction base said the primary content and the prompt to provide an instruction related to that primary content. Okay, so we're setting the text. Okay, we're asking the model to summarize for second grade students. Summarize the content that you are provided for the. Okay, so prompt is actually this instruction and the context, right? So let's see where we get back. Jupiter is, yeah. So let's do for a 5-year-old kid. Let's see how this, if it changes. Looks like it's the same. Very, yeah. Complex prompt. All right, so this is what I think where you would provide the actual context, I guess, right, on how do you want it to behave, I guess. Yeah, set to sarcastic. Okay, so we're telling the system that you're a sarcastic assistant. Uh, the user is us, so this is what we're saying. Who won the World of Series? What do you think? Okay, so we are providing an answer here. Are we providing an answer for the actual assistant to return? So let's see. Why do I need to provide? Oh, because it's going to do the next one, maybe. Okay. Let's see. That's very slow. I don't want to complain. Do people like this, me going through this, or are you just do you have this open in a tab somewhere and you're not really paying attention? Um, oh man, why is this taking so long? Shouldn't be taking so long. Ugh. Both. Yeah. Yeah. And I guess it took you that long to respond because you probably had it in a tab somewhere and you heard an audio and a question and then you had to find the tab. All right, why is this taking so long? It shouldn't be taking so long. I'm really curious to see the response here. I live very far. What is very far away? That's very all right. Should we give up on this or just leave it here? I guess this is the last thing, but I'll leave it. I'll leave it running, and then hopefully, as we continue here, we're gonna get a response back. All right. So how does this relate to our startup to bring AI innovation to education? Why are they linking to things? So they had a blog post. Okay. Um, Personalized learning. Okay. So Amazon might ask, analyze. Okay, so there's different end users or users. Okay. Check out prompts for education, an open source prompts library curated by education experts. That's an interesting thing. Let's see. Prompts for edu. Okay. There's a prompt. Okay. All right, so let's say we're an educator. Let's see what's here. Lesson planner. The prompt asks, assisting a teacher in creating a lesson plan. Oh, that's interesting. Okay. You're a friendly and helpful instructional coach. First introduces and next. Oh, interesting. Let's see how this is still running. 3 minutes. What the hell is is Chat GPT down or something? Let's see how this reacts here. Hello. I just copy pasted the prompt from here. I'm an instructor coach. I'm here to assist you in planning and engaging an effective lesson. What topics are you planning to teach? I don't know. What are we planning to teach? Let's say generative AI for high school students, maybe. They don't have any prior knowledge. Okay, that's interesting. It actually let's look at the prompt. Wait for Yeah, that's interesting. Given all, they create a customized lesson plans. That's pretty interesting. It's like a library of prompts. Uh, learning goals. What would you like your student to understand? Uh, uh, they should. The goal for this lesson is to understand the importance. Let's see. I'm making stuff up here of generative AI. Create a lesson plan. Okay. I'm curious how much different would this be if it was something else, like a different topic? But would you like to change anything? Oh, it looks good, I guess. Yeah, it's very high level, but interesting nonetheless. All right, let's go back. This one's still running. Okay. Well, let's keep it running then. Prompts. What is prompt engineering? Yep. Optimizing prompts, custom quality responses. So design the initial prompt and then refine to improve the quality. Trial and error. Yeah, which is what makes it harder. Okay, tokenization. Models. These are base LLMs, how it's getting processed, and how the model can now see tasks. All right, sequences, tokens. We talked about this. Tokenize, same prompt and different models will tokenize the same prompt in different ways. They're trained on tokens, not on raw text. Okay, so the way that prompts get tokenized has a direct impact on the quality. Try tools like OpenAI Tokenizer. Okay. Copy in your prompt and see how that gets converted. Paying attention how white space characters and punctuation. Note that this example shows an older. Okay. So this is the actual. Where I opened it somewhere. Is it here? Yeah, it's here. So let's see. What do I want to do for the prompt? Let's go back here. Okay. So also we're gonna create a lesson plan for. Oh, nice. For generative AI. Let's do this. Or we can do an example, right? Okay, so it's one token is about 4 characters. Okay, makes sense. Yep. So the prompt is tokenized. Predict the tokens in the sentence. They're trained in good sense, statistical. Yeah. They don't understand the meaning. They just see a pattern and they're able to complete it, right? And again, predict until they're terminated. Yeah, we can do OpenAI Studio. Okay, this is where instruction tuned. Okay. Instruction tuned LLMs start with the foundational model and fine tune it with examples. Okay, that's what the message is. Yep. That's where that chat ML came into play, I guess. Introduction to okay. Yeah, the response oriented. Okay. Let's use these techniques to train the model to follow instructions and learn from feedback. Better suited for practical. Let's try it out. Okay. Visit the prompt above, but now change the system message to provide. Okay, so it does the context. Summarize the context you provided with a summarize content you are provided. Okay, so we could actually go. Let me close this one. This is still running. I'll stop this. I don't know why is it. Did it say anything? I'll rerun it again. Maybe it's faster this time. But oh yeah, it is. Okay, so maybe it was something. Oh yeah, so it was like it was sarcastic, I guess. All right, let's close this one. And over here, we can say summarize the content you're provided with for a second grade. So you're gonna keep the results to one paragraph. Okay, so let's get some text. Okay, so I'm just copying some text. OpenAI generator. Here's a simple. Oh, that's interesting. 3 to 5 bullet points. Okay, so that was we provided the context, right, on what we want to get out, like extra instructions, and then the actual, here's the input that you should apply the uh, uh, whatever instructions we gave you on, right? All right. See how results. Yep. So we could see, yeah, and then we could change this and say something else. That's interesting. Yeah. Why do we need? Yeah, I think we know why we need it. Fabrication. Oh, okay, so that's where yeah, we tried this one. That one was from the Martian War, right? Yeah. Oh, we could say what happened. Let's see. What happened in Martian War of. I guess it'll probably say I don't have that information or something. Yeah, it's pretty smart. Not a real historical event. That's good. Okay. 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 GitHub Copilot. Yeah, this might be an interesting. I'm not going to go through all of this right now, but oh, it just takes me to this one. But yeah, GitHub Copilot, if you haven't used it, it's really, it's extremely helpful when you're writing code. It's a basic prompt. Say, yeah, we did this. And then complex was so this was the helpful. I think in the code, it was sarcastic, right? Simple query. Simple remote sensitive format. Yeah. Oh, yeah. And then we could probably say, if we do this, let's say we want this as keep the results to one paragraph. Keep the results should be in a JSON format of your choosing. Let's see what it does now. That's interesting. But we could say each. Yeah, this is where being specific and actually doing like trying things out, trial and error comes in. So let's say we wanted to get this summarized content in like a JSON format, right? Instead of like plain text or just text, I guess. So we could say keep. Provide the results in a JSON format. Let's see how this works. Each as an array of strings, I guess. I don't know. Well, let's try. Yeah, this would make sense, right? You get an array of strings for each like summarized portion. Yep. Fairly open. Okay, instruction and then content. Okay, so this was our instruction, and the content was whatever we provided there. The primary content examples. Okay, so give it examples. So this is where I would say, if I go back to that blog example, this is where I would say rewrite this or summarize this in the voice and style of these 300 articles, right? Okay, so example, sunshine, okay. So prompt. It's a number of examples, 0 shot, 1 shot, few shot, okay. 3 components, task description, few examples, the start of an example. Baseball, okay, so it infers based on the examples. Okay. Inferred, okay. Cues. Summarize this. Oh, okay, and then you provide the start with this pretty much, right? And it can continue. Prompt templates, simplest form, yes. Okay, let's look at the template here. Prompt template. Okay, so once you actually know what your template is, then you would go and like templatize it, I guess. Yeah. At scale. Prompts for edu. Tuning, formatting, prompting best practices. Okay. All right. Let's see. What is the time? Oh, wow. It's been an hour and a half. I'll go through one more and then maybe like continue. What is the next one? Creating. I wanted to write some code, but I guess there's a lot of. I mean, it's still useful, but prompt engineering. There's like a whole science behind this and techniques. Chain of thought. Correct. Oh, okay, so you would give it an example, right? Chain of thought. Oh, okay, so you steer it towards like instead of asking a direct question, you give an example first and then ask the actual question. Give an example with an answer and then the actual question. Generated. Yep, this is the interesting one for me. Insurance company product. Okay, makes sense. Yeah. Variable, but then you also have to figure out how do you want to split the whole prompt, right? Because there is a limit, right? You're not going to have like 10 lines, right? If you're talking about, in my case, blog posts, right? To optimize the prompt, clearer on what it can. Okay, trial and error. Okay, so you can more specific. Okay, so this almost feels like the prompt engineering is almost like the whole let me write like if else statements and some set some ground rules in a way, but you're just doing it in like plain English, plain language instead of like programming language, which I guess makes it more. I don't know. Is this easier or harder to teach to someone who doesn't have like computer science background than actually teaching them some code? I don't know. It's probably simpler, but it's not the way that people typically think, right? Um, software engineers, let me put it that way, right? This is very like software engineering type of thinking and writing things down, right? Um, okay, least to most, break it down. Okay, bigger problem. Okay, so instead of saying I want to start a business, how do I make whatever kind of money, you actually break it down with different things. Five, how to perform data set. Oh, okay. Oh, no, this is even like the other way around, right? And then you could drill into each one of these and ask or prompt for specific things. Self-refine, create, prompt, suggest 3 improvements. Okay, it's an interesting one. Myeutic, what the heck is myeutic? I have to Google this word. Oh, I can just do the. All right, so Socratic mode of inquiry seems to be okay. All right, well, give me an example. So, reduce. Ask the question for each part of the answer. Ask the LLM to explain it in more detail. Discard the parts, and then repeat 2, 3. How can I create a crisis plan to mitigate pandemic? And there's another typo or bug fix for someone if they want to do it in the repo. Okay, so identify that. Okay, it's an identify 5 steps, but can we determine if this is correct? Explain each step. Okay, explain the first step in more detail. What are the risks? Okay, to make sure, so I ask to explain the first reason. Hope it's consistent. In a pandemic, which is the biggest risk and why? Loss of life, right? Okay. Okay. 2 biggest risks. Okay, so you're basically. Okay, well, I see checking it, right? So don't trust the LLM blindly. Verify the output. It makes sense. Yeah. Non-deterministic, different results each time. Generate code, and then if you run it again, you get a slightly different response. Yep. So is the varied output a problem? Depends on what you're trying to do. Yeah. Okay. All right. Temperature. That's the randomness. Most deterministic. One is the most varied. The default is 0.7. And then you probably, if you run it with the low temperature, right, it's going to be more deterministic, meaning it's going to be the same. If you run it for the same thing, I guess. Yeah, there's only a tiny difference. But then if you set the temperature closer to 1, it's going to be differenter, more different, I guess. Good practices. Okay, here's a assignment. Self-refine. Oh, okay, so we would do this, right? So we would actually, let me copy this whole thing. How would you refine this? We would say, give me, provide 5 suggestions on how to improve this code. Let's see what it says. Flask, okay. Several ways the code can be improved. Error handling. Yep, we're just blindly reading the name argument. Yeah, that's recognize that. Input validation, yeah, that makes sense as well. We're just outputting the name here without validating anything. Logging, yep. Host and port, yep. Oh, and then it actually goes, and this is pretty useful. So escaping it, doing a try catch, and then specifying the host and port. This is pretty good. You can imagine creating a like a VS Code or some sort of an extension, right? Where whenever you like the code, do I have anything open? Let me see. I do, yeah. So let's say, let me copy this code, for example. If you could create an extension that would, whenever you open a file, right, you would always get like, just like you get suggestions. Let me do something. Blah equals. What is some wrong thing to do here? I guess this, right? This is wrong. Just like you get the errors like this. Uh, Imagine if you would get like suggestions on how to improve your code, right? Uh, in the similar manner as we have it here, right? So if we had this previous code, this might be an interesting problem or an interesting tool to work on, I guess. Interesting project. So we have something like this. Imagine an extension where it would show like either like a light bulb icon or something at specific lines. For example, on hello, right? It would show the icon. You would hover over, and then it would tell you, hey, you're not validating your input, for example, right? And then it would tell you how to do it, or if you click on it, it will actually change the code and do it for you. This is not a bad idea if anyone wants to spend some time working on this. Challenge. All right. Well, advanced prompts, and then we have what is building text generation applications. I think I'm getting close to 2 hours, and I don't see a lot of people uh, uh, here anymore. So maybe it's time to stop and then continue uh, some other time. I think it might be interesting. Like I'm interested in doing this project now where it's a VS Code extension where you can run it. It's gonna ingest the current code, the current file with the code that you have, and then it's gonna provide you suggestions. Might be a fairly simple thing to do. Maybe I'll start on that, and maybe the next stream is gonna be me working on that or going through this, continuing the course, I guess. Well, anyway, thanks for people who showed up. Um, find it interesting, let me know. You can find me on Twitter. And have a good rest of the day, and I'll see you next time. Bye.